Is everyone able to hear me? Mohan, Rajshekhar, Ramu. Okay, cool. Yeah. So, hi everyone. This is Surya Pachipala and I would be presenting you the demo on Hadoop and Big Data. To provide a brief introduction of myself, I'm working on this Hadoop and Big Data technology for the past 2.5 years. I basically work for credit cards and fraudulent detections using data analytics and visual analytics. Yeah, we use a variety of big data tools for fraudulent detection as well as balance calculations of credit cards. Yeah, and to let you know how this particular demo session proceeds, I would talk about what is big data, what is Hadoop, what a cluster is, right? I'll just introduce you with these terms. What is MapReduce, what is HDFS, right? These are technical jargons of Hadoop are something that I'm gonna introduce you with. Then I'm gonna talk about what this particular course contains. What are we gonna see in this particular course? Yeah, I'll walk you through all the course contents and what type of case studies and all the details that we are going to deal with. Okay, so to start with, I will start with an explanation on the term called big data, because when you hear about something called Hadoop, the most frequent term that you would be hearing is big data. So it's important for us to know what big data is before learning about any framework like Hadoop. Yeah. So what is big data here? Big data is collection of larger data sets in the range of petabytes, exabytes or zettabytes, but not usually in the range of your megabytes or hundreds of gigabytes. It should be in the range of some thousands of gigabytes or terabytes or petabytes, exabytes, zettabytes. It's very huge. So big data is collection of larger data sets which are in the range of petabytes, exabytes and zettabytes. But there is one more thing here. Big data is something which cannot be stored or analyzed in RDBMS. Why? Let's concentrate on these 2 points here. Why big data cannot be stored in RDBMS? First of all, if you look at the current trend, if you look at Bank of America per day it's producing 12 terabytes of data. Similarly, we have British Telecom which is producing 9 to 12 terabytes of data, and New York Stock Exchange per day producing 9 terabytes of data. Facebook per day producing 25 terabytes of data. I mean, these are the size that they are producing per day. That means the amount they are producing per day is very huge, right? The data that they are producing. But when you look at other side of the coin, the storage mechanisms to store such huge data are not being produced in that lightning fast manner. They are definitely not that fast. When you look at RDBMS, will RDBMS able to store almost like petabytes of data per month? Definitely no. If it let's assume it is able to store it. But at the end of down the lane, what happens is, if Facebook is producing 25 terabytes of data per day now, definitely down the lane after 2 years, it would be definitely producing almost like 40 terabytes of data per day. So in that case, if they had to use RDBMS to store the data, down the lane after 2 years or something, there will be no physical space left at Facebook data center to add few more hard disks. Because they got to add some external hard disks or magnetic tapes to store the data. At the end of the day, there will be no physical space left, that's for sure, if they are following traditional way of storing the data. It's not only Facebook, it's just not Facebook, because we know that it's a social networking site. Obviously it would produce huge amount of data. Then how about other banking organizations like Bank of America, Deutsche Bank, Citigroups? There are many other banks, JP Morgan, investment banking. So all these are producing again very huge data. When you swipe your credit card, when you swipe your debit card, the transaction itself is a data. They got to record all these transactions. If you are receiving your month-end statement, your cycle end date credit card statement or your debit card statement, everything is data here. they have to calculate your amount. That means they got to process this huge data. So everyone has to look for some optimized way of processing or storing the data, but just not your traditional way of storing the data. That's the first point. Big data is something that is difficult to be stored in RDBMS. And big data is something which is difficult to be analyzed in RDBMS. Why? What is RDBMS here? It's a relational database management system. That means there will be relations between the tables. When I say that, there are something called primary keys, there are something called foreign keys. Yeah, in order to derive the relations, we have lots of joins on your RDBMS. So let's assume we have two tables in RDBMS. The table 1 has employee ID and employee name. Table 2 has employee ID and employee designation. Let's assume both of these tables each has 10 billion records. 10 billion records. So when I had to query this table 1, just query, select star from this table where name starts with something like starts with S. So when I'm filtering some data, obviously it is going to take some time when I had to operate on 10 billion records. That's for sure. But assume a situation where I will have to join this table 1 with table 2. My condition would be more pathetic. It is going to take a lot of time because you are deriving a relation between two tables here. On top of it, you have your primary keys and foreign keys. So when you are having a lot of constraints on your RDBMS and when you try to query the data with a relation, definitely it's going to take a lot of time. But that's not the current situation here. All the users expect to have the result and very lightning fast. They are not going to wait for some time. Yeah, if that's the case, definitely RDBMS cannot be used to analyze your big data. Definitely. So reiterating the definition of big data is a term. It's not a technology. It's not a framework. It's not anything. It's just a term. Big data is a term used to denote larger data sets in the range of petabytes, exabytes, zettabytes, or even more, which is difficult to be stored or analyzed in RDBMS. So having learned about the definition of big data, then what is the other alternatives to store this big data? There are many tools. There are many frameworks. Hadoop is one such framework. There are databases like MongoDB. There is Cassandra. There is something HP tool called Vertica. There are many things. There are many things in the market currently. So our point of discussion would be on Hadoop. How Hadoop is able to deal with this big data, differing from traditional way of storing the data or analyzing the data. How Hadoop is able to do this? So let's look at what is Hadoop first of all. Is Hadoop a technology? Is Hadoop a tool? Is Hadoop a file system? Or is Hadoop a database? No, not all this. Then what is Hadoop? Hadoop is a framework. Hadoop is a framework written in Java. When I say framework, what is a framework here? Framework is something where it will have group of components which can be attached or the components which can be detached. It's a very flexible thing, flexible entity. Framework is a group of components which can be attached or dispatched at any point of time. So Hadoop is such framework which is written in Java, which allows distributed processing of large data sets across clusters of computers using simple programming models. So that's the definition of Hadoop. But we understood Hadoop is a framework. But what is this distributed processing of large data sets across clusters of computers using simple programming models? So to understand that, we got to understand two important things of Hadoop. One is Hadoop comes with a distributed file system called HDFS, which we call it as Hadoop Distributed File System, and a programming model called MapReduce for parallel processing and generating larger data sets. So what is this Hadoop Distributed File System, which we call it as HDFS, and what is this MapReduce, which we are going to call as MR? So let's concentrate on these two technical jargons, and then let's come back to this definition and see what Hadoop is. So to explain you on HDFS or MapReduce, let me take a very generic example. I have a client who asked me to lift some 100 bricks from one place to another place. He has given me 100 bricks and he has asked, Surya, just lift these bricks from one place to another place. Okay, so that's my client's requirement. So when I was asked to lift bricks from one place to another place, I have recruited a person who can do that for me. But that guy, whomever I had recruited, he had told me, hey, I'll lift this 100 bricks from one place to another place, that's for sure. But I'm going to take something around 100 minutes. That means 1 minute per each brick is something that I'm going to take. That's what he has told me. Yeah. So when he had told me that he is going to take 100 minutes for lifting 100 bricks from one place to another place, I've told to my client, hey, the task which you have given is going to take 100 minutes for me. So what am I supposed to do? Then the client told me, hey, you're not going to take 100 minutes. Let's try to complete this in 10 minutes. So he has given me a very stipulated time frame of 10 minutes. So I have no other go. I have only one person who would lift these bricks from one place to another place. So what I did was I have recruited 9 more people. So totally I have 10 people in my hand. Yeah. So what I did was I've distributed 10 bricks to each of these persons and asked them to lift these bricks from one place to another place. As simple as that. Right? So each person has taken 10 bricks and put it from one place to another place. Now, when I have 10 persons in which each person would be taking 10 bricks, and obviously they would be taking 10 minutes, so combinedly my task will be done in 10 minutes rather than 100 minutes, because I have distributed my work and I have made these workers to work parallelly. So my work is done in 10 minutes. So the takeaway from this story is, when I have a task, when I am able to split the task among different persons, and when I am able to make these persons work parallelly, my work will be done in very lesser time frame. That's the takeaway. Now, what is this HDFS? Hadoop Distributed File System is group of file systems which allows to distribute the work. So rather than having one file system, I had 10 file systems here. So group of these 10 file systems is nothing but HDFS, because HDFS allows these 10 file systems to work in a distributed manner so that I can achieve my task in lesser time frame. But what is this MapReduce here? MapReduce is a programming model. Right? It has two technical paradigms. One is mapper, another thing is reducer. What is mapper doing here and what is reducer doing here? One thing, when I have 100 bricks, when I have 10 people, I have split 10 bricks to each person. First person take this 10 bricks. Second person take this 10 bricks. Like that I have split till the 10th person. To split this 100 bricks among different file systems, right? To split a task, a task among 10 different file systems, I should follow some mechanism to split. I cannot simply split it. Yeah, I should have to equally split it. I'll have to take care of many other factors. So mapper is something which maps the task among different file systems. Okay, mapper takes care of mapping the task among different file systems. So now that my work, a single work, is split among different file systems and it has been done by different file systems separately, right? When a single task is done by 10 different file systems separately, obviously my end result would be some scattered among these 10 file systems, right? So when my end result is scattered, I cannot ask my client to take this scattered result. I will have to combine this result and give it to him. So there comes the use of this reducer. Reducer reduces this scattered result into a single result and give it back to the client. So that's what your MapReduce is doing. Mapper is mapping the task among different file systems, and once the processing is done, reducer is something that is concatenating the result and give it back to the client. So that's what your HDFS and MapReduce on a high level. HDFS, group of file systems, which allows you to work in a distributed manner. MapReduce is a programming model which has two paradigms, mapper and reducer. Mapper splits the task, reducers combine the result. As simple as that. So any questions on this HDFS and MapReduce? So that I'll go back to Hadoop definition and explain in depth about what Hadoop is. Starting from Darshan, Mohan, Rajshekhar, Ramu, Samson, Srini, Srujan. Anyone? Probably you can raise your hand. You have an option to raise your hand just below. You can raise your hand so that I will just unmute you. You can post your queries. If you don't have any questions, please just ping you don't have any questions. You have a chat option wherein you can ping your questions as well. Cool. So, Mohan is asking any other live example. There are many live examples I can give, but just to introduce you with HDFS and MapReduce, I've given an example. Just to talk about on a high level, probably I have a task of finding something around best selling. I mean, let's talk about in an insurance domain. I have group of claims from different parts of the globe, like US, Europe, Canada. Right? I have a file, I have a data set which is a very huge data set, right? I wanted to find out okay, let me do this way. I have a file and I wanted to just process this particular data set. Yeah, and I wanted to I'm doing some transformations on top of this data set. To just put this in a very easy manner, I've just taken this example. So when I had to process a file, when I say processing, I'll have to take each and every column present in this file and I'll have to apply some transformations on top of each of this column, right? So that sort of processing. So rather than processing this file with an individual resource, when I say resource, it can be a process ID in your file system. Rather than processing with a single resource, what I'll do is I will split it across different file systems. You can ask me what is a file system here. It's just a normal machine or a CPU. Okay, so I will split this particular file into different CPUs rather than having a single CPU to work on this processing of this input data set. So when I have split this among different CPUs, so my work will be split among different file systems. So that particular splitting, because I cannot just split like I wish, I'll have to write some algorithm to split it. So when I write that algorithm, I will write it in Mapper. Okay, not just splitting. I'll have to split the task among different CPUs and I'll have to make them to process this particular data set, the split of your data set. Okay, so when these resources are analyzing these data sets or processing this split of data sets, at the end of the mapper code, they will be done with processing of this particular data sets. That's fine. Now I will have this reducer which would combine the end results from all the CPUs and can make it as a single file and give it back to the client. So this advantage of this particular processing is, rather than one CPU working on that huge data set, what I did was I've split the data set into some 10 parts and I've made 10 CPUs to work on it, and at the end of processing I've made one CPU to combine all this result and give it back to the client. That's what we are doing here. So hope this answers your question, Mohan. And okay, so there are a couple of questions here. Srini is asking me, do we have to know about Java to learn this course? Srini, just give me some probably 5 to 10 minutes. I'll talk about the course contents. Then you will get to understand whether Java is required or what is required for MapReduce. Just give me 5 to 10 minutes, Srini. And Ramu is asking me, MR is a Java programming. Okay. MR is a Java programming. Here we'll still write any Java programming. Yes, Ramu, we are gonna write some programming. That's why I told MapReduce is a programming model, right? But let me give clarity on this. Like I said to Srini, just give me 5 to 10 minutes on this. Darshan, what is an example of a reducer? Like you said, file system could be a CPU. What could be a layman term example of a reducer? Yeah, even reducer is a file system. Even it's a CPU, Darshan. It's not different from your mapper, except from the fact mapper is splitting the tasks among different file systems, and reducer is just concatenating the result of all these file systems. But at the end of the day, reducer is again a file system like a CPU. Exactly. I'll come to the point. I'll come to the point what a cluster is. Then you'll understand it better. Yeah. So any more questions here? Can I proceed with the definition of Hadoop? Srini had posted me, is big data going to replace RDBMS? I would say no. Big data is not going to replace RDBMS. Why is something probably, let me put it this way. RDBMS is good at handling smaller data sets, whereas Hadoop is good at handling the larger data sets like big data. So there is no comparison between your RDBMS and Hadoop except for the few points. But to answer your question in a straightforward way, big data is not going to replace RDBMS. Yep. Let's take this general questions to till the end of the to the end of the this particular demo. Yeah. So coming back to the definition of Hadoop, Hadoop is a framework that allows distributed processing of large data sets across clusters of computers using simple programming models. So that's what we have discussed. Meanwhile, we had discussed about what HDFS is and what MapReduce is. And definitely MapReduce is a programming model. So now let's look at what a cluster is. Then all your questions would be, few of your questions can be nullified. I have a system or a CPU. I'll call that as a node. When I have a group of nodes, I'll call them as a rack. Like I told, when I have a system or a CPU, I'll call them as a node. When I have group of nodes, I'll call them as a rack. When I have group of racks, I'll call them as a cluster. So cluster is group of racks, rack is group of nodes. That's it. So rather than having a single system or a CPU to process my data or to store my data, I have group of file systems grouped together. So first of all, I have group of file systems grouped together as a rack and group of racks grouped together as a cluster. Cluster is group of racks and racks as group of nodes. I'm using different terminologies here, either node or CPU or file system. All the things denote the same thing. So cluster is group of racks, rack is group of nodes. So you can ask me why to split a cluster into different racks. This allows you to process or to make your cluster available at any point of time. That means, let's say in general situations, you will have one rack located in one physical location, other racks located in other physical locations. Let's say rack 1 is located in North America, rack 2 in South America, rack 3 in probably Asia Pacific. So due to power loss or due to natural calamities or due to network loss, one of your rack has gone down. Rack in North America has gone down, rack 1 has gone down. But your cluster still allows you to process your data because you have rack 2 and rack 3 in other physical locations and they are running fine. That means Hadoop allows you to have your business continuity though one of your rack is down. Though one of your rack is down, you can still process your data with the other racks available. Yeah, so that's the advantage of having a cluster. But another question that comes to your mind is, hey, this rack contains some different data and this two racks contain some different data. So when one of your rack is gone down, how are we going to work with rack 2 and rack 3? That can be a general question. But in Hadoop, we have a concept called replication. So whatever data that is present in rack 1 will be replicated to other racks available. That means the rack 1 data will be replicated to rack 2 and rack 3. Similarly, rack 2 will be replicated to rack 1 and rack 3, and same applies for rack 3 as well. So this allows you to have business continuity even though one of your rack has gone down. So how we are replicating all these terms comes under Hadoop architecture, which we'll be discussing in coming sessions. But to tell you on a high level, Hadoop has a concept called data replication, which allows you to replicate the data across the racks. Okay, so the bottom line of this discussion is cluster is group of racks, rack is group of nodes. Yeah, so let's go back to the definition of Hadoop once again. Now it makes sense to discuss about Hadoop definition. Hadoop is a framework which is written in Java that allows distributed processing of large data sets across clusters of computers using simple programming models. So we know what HDFS is, so we should be able to understand how Hadoop does distributed processing of large data sets. And we know what is the simple programming models. That means MapReduce. So how are we going to split the data and reduce the data using MapReduce programming model? And like I told, Hadoop will be always there with a cluster. So cluster is a group of servers or machines or CPUs, right, which offers local computation and storage. So when someone asks you what is a Hadoop, Hadoop is not a technology. Hadoop is not an it's not a term. It's rather it's a framework which is written on top of Java. Okay, which allows distributed processing of large data sets using HDFS and MapReduce. So that's the definition of Hadoop. And so far we have discussed about what is big data, what is Hadoop, what is HDFS, and what is MapReduce. And on top of it, we have discussed what is a cluster. I'm just introducing all these terms with you. Of course, we are going to dig in our coming sessions in all these jargons. Yeah. Now, so probably many people might have questions like, hey, do we need Java to write MapReduce? Of course, definitely I would say you need Java. But what if I don't know Java? That can be the second question. The first thing I will bring to your notice is as part of this course we are teaching Java as well, core Java. When I say Java, it's not just structs or web services and all this. It's just core Java. MapReduce has to be written in core Java. Okay, so as part of this course, the prerequisites for Hadoop is Linux and Java. And both these Linux and Java are being covered or will be covered in this particular course. That's first point. And probably some might say that, hey, I'm new to programming. So how am I going to survive in this Hadoop field? Probably let's discuss about this Hadoop contents. Then you'll understand what are the other things that are available. So this course is going to be for 40 hours. Yeah, daily it would be 1 hour. Yeah, and during weekends, probably after first week or something, during weekends it would be couple of hour session. So it would take 40 days to complete this particular course. Yeah, so the primary motive of this course is not just teach you technical terms. This course will teach only 20% of the technical terms. Rest 80% would be practical oriented. Sorry. I'm so sorry, just give me okay. So rest 80% would be practical sessions. So when I say practical, the objective of this course is to make you ready to work in real time as well as to give certifications like Cloudera or Hortonworks. So that's the primary motive of this particular session. So what course contents are we gonna deal with this particular course? One is, I will introduce in the initial days, I'll talk about Hadoop 1.0 architecture. Yeah, I'll talk about all the networking concepts, architecture, and all the details, because these initial terms are something that we'll have to go little slow so that you'll understand it better. Then I'll talk about the different use cases. I'll talk about different use cases that we might encounter, or where Hadoop is literally being used nowadays. Yeah, the real-time use cases are something that we are going to discuss. And then there is an advancement for Hadoop 1.0 architecture, which had come up with Hadoop 2.0 architecture with a very beautiful concept called HDFS Federation and YARN. YARN is yet another resource negotiator. So we are going to discuss about this terms as well, yeah, in detail. So at the end of this Hadoop architecture, you will have a quiz to answer. This quiz basically covers the questions that you might expect for Cloudera or Hortonworks. Yeah, that's the primary objective of this quiz. Not only for this quiz, on all the sections you'll have a particular quiz and a case study. So we will have a quiz on architecture concepts. Then once I introduce you with the architecture concepts, I'll talk about the prerequisites, which are Linux and Java, right? We will talk everything in real time. We will talk about all the commands. We'll see how to write some shell scripts when it comes to Linux. We will see what are all the editors that are available and the editor features. And I'll give you, at the end of the Linux session, I'll give you a case study to develop some shell scripts, right? Similarly, we will discuss about all the concepts of core Java, like all the things that are required for us to write MapReduce jobs, like we have inheritance, polymorphism, yeah, we have to know about constructors, yeah, how to invoke objects, right, how to write some methods. Everything is something that we are going to discuss as part of this Java session. And I'm going to provide you with a case study to develop some Java code with the concepts that we have discussed. And of course, I'll come to this particular Python later on. Yeah, why Python is being introduced here, right? Probably when I talk about ecosystem components, I'll talk about this Python. So now, after I introduce you with the prerequisites, what I'll do is, having Linux knowledge, then we are gonna install our cluster on our own, right? So when I say installation, I would do an installation here, and I will give you all the required softwares and a reference material. I'll give you a PDF which tells you each and every step. So once you attend the session and once you have this reference material, you should be good to install your cluster on your own, so that you can practice all your Hadoop commands on this particular cluster, whatever we are going to develop. We are going to develop on top of VM Workstation. So this particular document talks about that particular installation, how to install the cluster. So for installing cluster, we need Linux, obviously, because we are going to do that on top of CentOS operating system, or we can take it as a Linux. So obviously you should learn some Linux commands. So that's the reason why I have introduced you with Linux as a prerequisite. So once we install cluster, we are going to talk about different directories, configuration files, port numbers, inbuilt scripts, right? And how a real-time cluster looks like. All the size details are something that we are going to discuss. And then once we install our cluster, we are going to talk about HDFS and its commands. And again, your Linux is going to play a key role, because the Linux commands and HDFS commands are almost in sync, almost 80% in sync. So it would be easy for you to operate on HDFS when you already know Linux. So that's again one more reason to introduce you with the prerequisite called Linux. So once you talk about all the HDFS commands available, we'll talk about the scenarios where we apply these commands, and we are going to look about how to fine-tune your cluster and how to write some custom scripts on top of your HDFS. All these things are something that we are going to discuss, and once we complete, you are going to write a custom script building HDFS and Linux commands. All the documentation will be given on the HDFS commands, and again you'll have a quiz here. You'll have to work on a quiz which talks about the commands that are available in HDFS. So once I talk about that, I will jump into the most important part called MapReduce. So now I'll answer to your questions like, is Java required for writing MapReduce? Of course, Java is required for writing MapReduce. Java is very much required. It's a prerequisite. So that's the reason why I'm introducing you with Java. So once I introduce you with Java, I'll talk about MapReduce architecture, different phases of MapReduce. We are going to see how to develop a MapReduce code from the scratch. I give you a requirement, right? I give you an input data set. How do you develop MapReduce? So we are going to develop one MapReduce from the scratch. We are going to discuss about different case studies or use cases of MapReduce, like till the point like we will analyze some image files using MapReduce. When I say image files, it's binary data. Yeah. So I'll talk about different phases of MapReduce: mapper, reducer, splitting, sorting, shuffling, combiner, partitioning, merging, spilling, many concepts. Yeah. So obviously we are going to work on a case study here. Yeah. You are going to work on a real-time case study, which is nothing but customer sentiment analyzer. I'll give you the input data set, right? I will give you a PDF document which tells what you'll have to do, but it will never talk about how you'll have to do, right? So you'll have to work on a logic and you'll have to develop the case study from the scratch, right? And you can ask me, hey, I'm new to Java. So how am I going to survive in this Hadoop field? That's fine. If you are new to Java, if you have any other programming experience, you can use a concept called streaming, which is nothing but you can develop your MapReduce code in any high-level programming language available, like Python, Perl, C, CPP, yeah, Ruby, anything. So as a part of streaming, I'm going to talk about MapReduce using Python. That's why I will talk about Python for one session. I'll introduce you with basics of Python, and I'll develop some MapReduce codes using Python. This is what we call as streaming. So at the end of streaming, again, you'll have a case study and you'll have a quiz on entire MapReduce section of both Java and Python combined. You'll have a quiz. So if you could notice here, for every section, you will have a quiz, and for every individual section, you'll have a case study. Now, my next question would be, hey, I'm new to Java. That doesn't mean that I know any other programming language. I'm new to other programming languages as well. So how do I survive in this Hadoop field? Yeah, that can be your another question. So don't worry, you have Hadoop ecosystem components. If you are an SQL guy, if you are not a programmer but you are an SQL guy, what you do is the same sort of processing which you do using MapReduce can be done using something called Hive. Now we enter into the ecosystem components of Hadoop. Hive is another data warehouse on top of Hadoop. So if you are new to Java or any other programming language, obviously you can work on Hive. You can process or analyze your data using Hive. It's a data warehouse on top of Hadoop. So we are going to discuss about Hive till a level of proficiency, all the advanced commands, and we are going to discuss about writing advanced features like partitioning, bucketing, sampling, yeah, serializing, deserializing, and all the stuff. But on top of it, we'll discuss about developing some user-defined functions in both Java and Python for Hive. So again, your Java and Python will be required, but not to a very great level of how we used it in MapReduce. Okay, and again, at the end of Hive, we are going to work on a case study, analytics on telecom data sets, and we are going to give a quiz as well. And now the ecosystem components are plenty. So as part of this course, we are going to discuss about the most useful ecosystem components like Hive, Pig, Scoop, Flume, HBase. And I'm going to talk about a scheduler like Uzi and Autosys. Right? So these are the ecosystem components we are going to discuss as part of this course. Yeah. So if you are a Java guy, yeah, it will be very easy for you. If you don't know, that's fine. I'm gonna make you comfortable with core Java. If you are not at all a programmer, you can concentrate more on these ecosystem components like Hive, Pig, HBase, Scoop, and Flume. Yeah. But at the end of every section, like let it be Pig, Scoop, Flume, everything, you'll have a case study and a quiz. So at the end of this course, you should be in a position to work hands-on on all of these ecosystem components or on a cluster, that it be MapReduce or any of the ecosystem components, and you should be able to crack your interviews, because provided we are answering many quizzes here, which gives you real-time exposure of how you can expect questions, or you should be in a position to give certification for Cloudera and Hortonworks as well. So that's the primary motive of this course. So like I said, as part of this course, we are also going to cover Hadoop ecosystem components like Hive, Pig, Scoop, Flume, HBase, and the schedulers like Autosys. Yeah. So this is the course which will be continued for 40 hours, and wherein 20% would be theoretical, rest 80% would be practical. So you got to work on many case studies and quizzes here. Now I'll take your questions. Probably let me go with Darshan. Okay, you can ping your queries here. I'll answer one after the other. Hive. Okay, Darshan is asking me what is Hive. Is the data component of HDFS like a backend system? No, Darshan, like I told, Hive is an ecosystem component of Hadoop, which is like a data warehouse on top of HDFS. So like how you do your analytics on top of your SQL, like MySQL or Oracle, you can do your analytics on top of your Hive, but it will be pretty much faster, 100 times faster than your RDBMS, because at the end of the day, it uses MapReduce in the background. You write your SQL queries, it will convert that into MapReduce and it will work. Of course, NP, okay, let me come one after the other. Are the ecosystem components used for only admin or analyst purpose, or is it required in development as well? I will not say admin is required to know in depth of all these ecosystem components, but yes, of course, I agree that even admin has to understand all these ecosystem components, but it is primarily used by data analysts, data scientists, or the developers. So that's for you, Darshan. That's your question. Now, moving on to the next question, NP Duval. I learn SQL Server and I'm working on it, and I want to move to big data. Is that possible? Of course, it is possible, because we are going to work mostly on data analytics. So definitely it would be a very good opportunity for you to learn or move to big data or Hadoop, because when you are using SQL Server, if you are writing different sort of queries, we use the same sort of queries but in an optimized way to do the analytics. Yeah, that's for you, NP Duval. And Darshan, you still have more questions? Are each of these programming language absolutely required? I have already answered this. Java, if not Java, you can learn Python. If not both, you can concentrate on ecosystem components. But I would definitely say Java is a definite prerequisite. Python, it's like an add-on. I will not say that it's pretty much required, but Java and Linux are definitely required. That's the point I wanted to make it. Yeah. And are each of these programming languages absolutely required? That's I've already answered. Can we just use Java, not Python? Of course, you can use just Java, not Python. Yeah. 40 hours, is that a daily course, or how is course scheduled? And Piduval. Okay. Okay, I have a few more questions at the top. I want to get certified. What is the process to get admin certification in Hadoop? Srini, to answer your question, you can get certified through Hortonworks or Cloudera. Yeah, that's the way you can get certified. Probably I will forward the links for you wherein you can find the certification. After this course, probably you will find almost like the things that you got to prepare, or how you got to answer your certification questions. That's for sure. And again, that's a good question, Samson. What is the objective of this course? To make us Hadoop developer or administrator? How much can help we get in to pursue certification? That's a very good question. See, my course would be covering almost like 60 to 70% of the developer part and 40% of admin part. Yeah. So the primary objective is to make you work hands-on as a developer or a data analyst or a data scientist, and I will be covering only 40% of the developer part. Yeah, I being a data analyst, right, I will be more concentrating on data analytics part, which would help you to make an developer or a data scientist. Yeah, only 40% would be on admin level. How do we get real cluster? Okay, Rajshekhar is asking me, how do we get real cluster hands-on? Rajshekhar, I will talk about different types of clusters here. We have a pseudo mode cluster. We have something called an distributed cluster. See, apart from the fact there is a just limitation of number of resources between pseudo mode cluster and the distributed cluster. Everything works the same, right? But of course, I'll have to agree that the time frame that you take for the processing of the data between your real-time cluster and a pseudo mode cluster will be different. But definitely, it's gonna give you an experience of a real-time cluster. There is no doubt about it. Just apart from the fact that you cannot expect it to be as fast as your real-time cluster. Okay. And Shekhar, probably you can just get in touch with Mr. Satish. Yeah, he will provide you all the details if you'd like to call me. Yeah, you can talk to him personally. Probably I think you have his number, Satish. If you don't, I can just ping that number. You may I mean, at the end of this course, I'm gonna give you his mail ID as well as his contact number. You can just get in touch with him. Yeah. And Shekhar, okay, that's your question. Ramu Paturi, I'm 2012 passed out. Can I get chances as a fresher? I'm 2012 passed out. Can I get chances as a fresher? Yes, Shekhar. Probably rather than me commenting on your question, you just log into LinkedIn or any professional networking site and just search for the options wherein you get how many opportunities are there for your profile. Yeah, definitely there would be chances, I can say. You said you'll cover about 60 to 70% of data analyst or developer or data scientist. That's correct. And 40% on admin. Absolutely, Darshan. That's what I'm going to cover as part of this course. And Shekhar, please get in touch with Satish. He will give you all the required details. And Rajashekhar is asking me, is Apache Cassandra going to be covered in the course? I am going to cover HBase, which is a NoSQL concept. Yeah. When I say Cassandra or MongoDB, all this belongs to NoSQL family. So when you learn MySQL, how we'll be comfortable working in Oracle? The same way when you learn HBase, you should be pretty much comfortable working with MongoDB or Cassandra. Yeah. So that's for sure. I'm gonna cover HBase in detail. That means a NoSQL concept in detail. So I'm not going to cover MongoDB or Cassandra as part of this course. I'm going to cover only HBase, which would talk about all the NoSQL family concepts. Clear? So like I told, I'm not going to cover MongoDB or Cassandra, right? I'm just going to concentrating on HBase. On top of it, I'll talk about NoSQL concepts. So probably this will answer your questions as well, Shekhar Konda. That's what you are pinging about MongoDB admin and Cassandra admin. I'm going to concentrate on HBase and NoSQL concepts. How many days this class will be? That's your question. Like I told, it would be 40 days, every day 1 hour. And during weekends, probably on your Saturday evenings, it would be 2-hour session. Okay. I'm going to talk about MapReduce, of course. Unit testing is something that I'll be covering. How do we test your MapReduce jobs and how to get comfortable before how to get confirmed that your MapReduce doesn't have any issues before migrating it to your cluster. Obviously, we are gonna talk about that. For practical, are we performing everything in locally or AWS? Yes, you'll work on your own system, which says that you're gonna work locally. on your own cluster you will be working, Mohan? That's your question. So hope that answered your question as well. MongoDB admin, Shekhar, I'm not a person who is working on MongoDB, so it's hard for me to comment on that. It's again a NoSQL. Probably you should learn NoSQL concepts. That's what I can say. I'm working on Cassandra. So, I mean, all these are NoSQL families. So when you learn NoSQL concepts in detail, then you should be able to work on that. MongoDB admin is something that is new to me, so it's pretty hard to answer. Can we finish the class before 40 days? I'll try to, Mr. Darshan, but I'm not sure if I can promise on that. And no, Shekhar, I'm not covering Cassandra admin. Yeah, I'm just taking Hadoop part. Ramu, what are the software requirements required to install for Hadoop? Just your laptop with a 4 GB RAM, right? And a space of 15 GB or 20 GB should be 15 to 20 GB is sufficient, right? On top of it, you can install your cluster. I have heard of n-gram algorithms. What is it? N-gram algorithms are something again which will be optimized way of analyzing the data. Of course, we are not going to cover that in this course, Mr. Rajshekhar. Or you cover Hadoop admin concepts? Shekhar, that's what I'm telling. My part of this course would be covering 40% of the admin concepts, and rest 60% would be on top of admin level, analyst level and developer level on the data scientist level. Yeah. So we are done with the course basically. So just giving importance to others' time frame as well. Probably I'll take 1 more minute and answer your questions. Yeah. Yes, Rajshekhar, that's what I'm repeatedly, Shekhar, I'm repeatedly telling that this course would be covering 60 to 70% of the developer part, rest 30 to 40% would be on admin part. Darshan, please go ahead. Yes, Srujan Angadi had pinged me, having knowledge of core Java is sufficient. Yes, it should be more than sufficient. Dual, you can check with Mr. Satish on all the details. Satish, can you please ping your mail ID and contact details to everyone, please? And the session would be starting from tomorrow at 7 AM. And Darshan, with our local mission with just one CPU, yes, of course.
Hey, so yeah, Satish here. So what we can do is some people join from other company as well. So we'll ask them to contact their consulting company to get more details.
Definitely.
So everyone, the session will start tomorrow evening 8:30 PM EST. That will be 7 o'clock Indian time as usual time. So if you want to get more details, you can contact Srini. If anyone joined from Srini side, you can just talk to Srini on the schedule. And if anyone joined from Tech Trainings, you can note it down my email ID for more details. I'm just putting my email ID in the chat box. You can check it out, my email ID and contact number. Thanks everyone for joining the call.
Thank you so much everyone for spending your time.
Just a minute, Surya, I'm just mentioning my email ID and
Definitely. Please go ahead. Yeah.
Yeah. Yeah, everyone, you can check it out the chat box for email ID and contact number. Okay. Thanks for your time, Surya, and thanks for joining everyone. Yeah, have a good day.
Bye-bye.
Good night, guys. Take care. Yeah. 1 second, Surya.